Hello, good afternoon, everyone. I'm really glad to be here in person with you. And as an engineer, I'm doubly glad, and you will see the reason shortly. So thank you very much for attending my presentation today. And I want to tell you how XR technologies can help us drive democratization in engineering worlds. But let me first start a little bit about saying about Siemens. I don't know if you know Siemens. Siemens is a technology company headquartered in Germany, but we are present around the world. We have more than 300,000 employees, and our mission is to transform the everyday. By combining the virtual and the real world, we enable our customers to master the digital transformation and tackle also the sustainability challenges. And as you can see, as a company here, we are present, our customers are present in multiple verticals and application areas. So we have very broad field of customers here. And just to give you an idea about our products and our services, we commute in cars that are designed with our tools. You may not know that, but Siemens is a leading industrial software provider, and these cars are manufactured in factories using our automation. We are the market leader in this field, and then also the cars are charged using our smart grid infrastructure solutions, like, for example, here, this charging station. But not only that, our solutions and products allows us to work in a healthy and safe environments, in buildings that are used have maximum efficiency of the resources, and we connect the digital and the real physical workplace. That's here an overview from our company. We have several industrial businesses. We have the digital industries. We are the software, the factory automation, the motion control, and the customer services, then the smart infrastructures, where we have for the buildings, electrical products, grid software, grid solutions, smart grid solutions, mobility, we're building trains, trams, underground wagons, and then we have our healthcare department, the Siemens Healthineers, which is a public listed company, but we have the majority of the company, and some further companies. And across all these areas, we have some services, some corporate functions, and among these corporate functions, it's corporate technology, where I'm coming from. That's the central R&D department of Siemens. And we, as a corporate technology, we have one mission, is we want to accelerate the customer success and the Siemens growth by leading the technology of tomorrow together. And as a department, we have a very deep technological know-how, and because we are a corporate unit, we are leveraging this expertise among all the different verticals in the company. And this is the last slide. I promise I will speak about the company. Our company has identified 11 technologies that are very crucial for the success of the company and our customers. And we have now bundled our research activities towards that direction, and Siemens Technology is clustered also the same way. So we have 11 technology fields. And these technology fields are data analytics, artificial intelligence, future of automation, user experience, and one of them is simulation digital twin, where I'm coming from. In our technology field, simulation digital twin, we are dealing with topics like next generation algorithms, or how can we speed up engineering simulation models and bring them into operation phase, system simulation, and human digital interaction, where I'm working on, my focus is. And just to give you an idea about our work here in this human digital interaction, we as a technology field, we try to disrupt this interaction along the product life cycle. And here I have just a small selection of projects that I have worked the last 2-3 years myself, starting from the concept phase, where we as a department have developed a real-time solver for finite elements. And we said, how can we demonstrate that and convince people that it performs real time? And then we came up with the idea, okay, let's make a VR application and allow the people interactively test it. So we gave them the controllers and said them, okay, with the controller, you can you can apply the force and define the magnitude and the vector, and interactively you get feedback for your actions. And everyone started believing, oh, that runs real time, fast. And then we don't stop there, but we're developing also concepts, how to drive mass customization in consumer products. For example, the second example from effective generative design, where we are using eye tracking technology combined with generative design to create personalized objects. In this specific example, we have used eye tracking technology from Tobii, and we have extracted some metrics, and these metrics, we managed to translate them in interest of the user. And by showing the user different pictures, for example, colors, materials, different types of T-shirts, we were managing to extract his interest, and using our generative design algorithms, we combine this information and create the best T-shirt for the person. And so far, we have conducted several studies internally, and the overall satisfaction, complete satisfaction, is above 85% of all participants. But we don't stop there, and we want to unleash the human productivity and creativity by allowing them to use and create sketches in VR. And for that, we have partnered with a startup called Magos from Greece, where we're using the VR hand gloves, and we're trying to use these VR hand gloves in industrial context. We have created an application where the user can easily create his own sketches, and we have integrated some CAD functionalities like Boolean operations where you can merge objects, you can cut them, you can use the common areas, and the result you can export and import in a classical CAD tool at the end. But we don't stop there. We have in engineering developed an environment where you can bring in the same environment simulation and CAD information to just make easier the post-processing, so we have all the information in one place. A new trend is the robot milling, and the robot milling is a rather complex process because depending on the position of the object relative to the robotic arm, it has an effect on the accuracy of the process, but it's very complicated, and you need expertise to understand that. And for that purpose, we have developed a VR application where the user with a controller can position the object in the 3D space, and he can get instant feedback, either visual, with a color on the object, or with a diagram about the accuracy of the process. And finally, in the operation phase, we have developed augmented reality application coupled with executable digital twins, which are simulations performing real time to augment information to the operators. Because we cannot have infinite number of sensors, we're using virtual sensors there, which provide us more information and augmented information to the operator. He can take better decisions. Or we can offer him some other information like what's the rest useful lifetime of a critical component, or what's the status of the overall process. As you saw before, all these applications have one common characteristic. In the back end was complex simulations, but the front end was really simplified for the user to interact and get the results. And we have developed these applications, but each time was done from scratch, more or less. And we said, why we don't do that more systematically? Why we don't address the topic in a central way, so we can develop one platform that can tackle multiple problems. And that's how we end up with our proposal today here. And the reason is, in the engineering world, we have currently two major challenges. The first one is we have product development in silos. That's a common truth, and we are working in a discipline-specific environment, so we may have tools that store the data centrally and orchestrate this data, but the simulation results can be retrieved and interpreted only from the experts. In this case, for example, a mechanical expert can interpret the mechanical results, but he cannot understand what the computational fluid dynamics are or the acoustics are, or he cannot access them from multiple reasons. And what's happened today is the interpretation of these results from the other experts relies on personal exchange and contact. So the experts have to meet and exchange information about the results. In this case, for example, if you have a field engineering doing a test and he needs some information from the simulations, because the simulations offer 360 information for an experiment, while the tests have on just discrete position of the sensors, he has to call the simulation expert, ask this information. Himself from the field, he cannot retrieve the data because it's very difficult to interpret it with the current situation. And if we go outside the core R&D team and we see the other stakeholders, like the suppliers, the managers, the information that they get these people is very limited to the generated presentation and reports. And they don't have any idea about the holistic approach, why we ended up with this design, why we took this decision before. And the second challenge there is the complex UIs and user experiences nowadays, the very bad user experience with the most tools. Companies admit that they want to adopt more, to increase the use of simulations in the R&D process and increase that, but they struggle with the adoption because they face major challenges like the lack of expertise of the people or the lack of trainings, because the trainings takes a lot of time, which is not always available for the experts, and of course the complex UI that most tools have nowadays. And so it ended up today that user experience is among of one criterion to the companies when they select a tool for the tool chain. But when we're speaking about user experience in UI, we must have in mind also the younger generation that are about to come, because they grow up in a gamified environment and they expect the same experiences later in the working environment. So if we fail to offer them such experience, we're going to lose the talents. So we need a new approach to drive the democratization and make simulations more tangible to a broader base. And one other thing here that I want to add to that is that was the engineer life before the COVID-19 restrictions. People were meeting engineers in front of a screen, pointing what's there, what's that, and they have interactions, and they were discussing about the project. But now, with the COVID restrictions, everything switched to Teams. So one shares its screen, and the other just watches. It's very difficult to interact, and the information flow is really bad, and this has as an impact that the whole R&D process is a little bit slower nowadays, and we will have to make that faster. Now, coming to the democratization, we as Siemens Technology believe that there are 4 key pillars that can drive the democratization and simulation. The first one is the real-time collaboration, how we can bring different people from different disciplines in the same environment, exchange information, and everyone has access to the same information real-time. The second one is interactive simulations. That's the next generation of simulations where the novice users, especially in the concept phase, the very early phase, they want to have fast feedback for their actions. So if you are a novice user, you don't have the patience to wait for our traditional engineering tools, which takes hours, sometimes days. You want some fast feedback for your actions. Then modern user experience, which will help us to lower the entry barriers for them and make them more easy, tangible the simulation world. And finally, the cross-platform. Nowadays, people want to have access to the information when they need it and not when they sit in front of a PC. And for that reason, we have to make our simulation tools capable of running on different devices like tablets, phones, or even PC, VR, AR glasses, whatever is used from the user each time. And we sat together with my colleagues from digital industry software, the experts that we have there from the simulation and test solutions, and we said, okay, which use cases we have in-house where we can demonstrate this democratization has a huge impact for the users. And we have identified 3 use cases. The first one is the acoustics, the interactive ones. As you can see here, the picture that's a little bit small below, the acoustic experts, each one wears his headphones, sit around a table, everyone listens to a sound, and they have this heat map generating from the simulation tools. If you ask me, that I'm not an expert, I have no idea what these heat maps are about. Because sound also, it's about experiencing also, not only for something that's a user. What does it mean, this sound, in my real context, in my real environment in the future? Or how can I perceive it in a spatial? So first-person immersive experience is very, very important here. But the results has to be physics-based and not realistic, should be accurate, because we're speaking about industrial grade here, accuracy, and the customers expect that from our tools. The second one comes from one of our tools, SimCenter 3D. It's a simulation tool. It's a very powerful tool. It has a lot of fields of study. That's a huge advantage if you see that from the point of content. But if you are a novice user and you enter up there and you have all this physics and all these buttons, you are overwhelmed, you don't know where to start to. So it's a little bit problematic, and the easy path to the post-processing to analyze the results is not so happy, this whole process. But it's not only about the novice users, but the experts there told us that they want to have more immersive experience and more collaboratively environments. So that's why we said, okay, this also use case is interesting for our case. And finally, it's a novel, due to lack of time, I don't want to go into details with that. It's a novel process for testing, especially for the space industry. When satellites and antenna are going to the space, they have to withstand the test. This test is very limited, 120 seconds. And in these 120 seconds, we have to maximize the information we get in order to have a better understanding for our structure if it's going to withhold. And for that, we are using some sensors, but the sensors are specific number. We cannot use a lot of sensors. It's very expensive. It's impossible. That's why we have to augment simulation results real time there to the field engineers in order to support their decisions for the testing process. And having all this in mind, we have designed this collaboration platform. As I said before, we have realized that with Unity, because Unity allowed us to make very fast prototyping and pivot and get fast feedback from the users and improve them fast. And also, we could reuse some of their assets. We don't have to do everything from scratch for ourselves. And we have created connections to the SimCenter suite that we have. It's our portfolio. It's our software tools. We have connectivity between Unity and our tools. And also, we have provided connectivity to the sensor field data, real-time, to our platform for visualization. And also, you can upload other documents like presentations, videos, or other relevant documents for the project. And our platform works both on the premise and on the cloud, because some of our customers do not want that the data leave their premises. So we offered both solutions here. And here a little bit about the features. What we have managed to realize with our collaboration platform is that when it comes to the user experience, it's a cross-platform. As I said before, it was very important. It runs on PC, tablet, VR glasses, and AR with a tablet. It has a modern UI and simplified UI compared to the classical engineering tools. We have designed dedicated environments for the acoustics and offers real-time collaboration. And when we're talking about real-time collaboration, we have integrated voice IP here, chat, so the engineers don't have to leave the environment, but everything, all the services are incorporated in the same one. We have persistent annotations, and with the persistent annotation, we say that if an expert is not there present during a call, a meeting, you can leave a sticky note, and the sticky note remains there. When he later joins, he will find the information. And finally, we have the functionality of the screenshots, where you can take screenshots in the virtual environment. The picture is stored locally at your device or the cloud. You decide that, and you can reuse it for presentation on further purposes and discussions. And now comes the exciting part, the simulations. Here, we tried to provide some of the post-processing capabilities of our tools in Unity for the user, so he doesn't have to leave the environment. We have developed a parser and importer where we can really fast import. We're not yet real-time, but we're working towards that direction. Really fast the information from the simulations into Unity. And here we're speaking about gigabyte of files, of size of the data. So it's 5, 10 gigabytes, typically such simulation results. We have developed our own shaders for the heat maps, which perform in a few milliseconds. And the reason was that we have to support transient results, and the user doesn't have to see any latency. So he has to have a smooth transition. Clip functionality, so you can make some cuts, you can make some probe test the values at different locations very easy. We have developed our own graphed asset because we didn't find something that could cover the needs of engineer there. That's done, so we have done that from scratch. We designed that. We offer connectivity to the cloud, and our cloud solution called MindSphere, or SCADA, it's a system where you take the data from the field, the testing data from the field, and then also we integrated a novel acoustic engine that we are developing. And this engine offers industrial-grade accuracy. There are other audio engines out there on the market. They may deliver realistic example, but as I said before, they cannot provide the industrial-grade accuracy that our customers want from our products. And here, just an overview of a screenshot from our collaboration platform. As you can see here, it's very simple, and they keep clean. We try to keep that clean, relatively clean. We have 3 areas of interest for the user. The upper right one is with the collaboration part, where you can see the other participants there. You can start the chat function with the others, or you can go to the presentation mode. Then we have on the left side the bar, where we have the general functions. That's some generic function like laser pointer, activate to move the object, or you can leave the sticky notes there. You can take a screenshot, and the settings where you can change between dark and light mode, or you can mute yourself, change the voice levels, and things like that. And on the upper left side, we have the simulation tab, where we have all the information for the simulation part. And here we have some very basic functionalities. So here we said, OK, what are the functionalities that the most time a novice user is going to use? So we have limited the offers here. and to loading the geometry, load the results here, and some basic functionality for the post-processing. And here we have prepared some videos to give you a look. So that's the VR version. It runs with OpenXR, so we support Vario, for example, Oculus in this case, and also HTC Vive. And here it's very easy to manipulate the 3D geometry and rotate it and scale it. If you are using a CAD tool in your PC, you know that's not so easy, the scaling with a mouse. You need a 3D mouse, which not everyone has access to. And you can easily, here with a laser pointer, read the values at any location, not a specific knowledge, just point somewhere and you read the value. And on the back side, you have seen, I don't know if you have seen, you have here integrated the presentation. So you can have all the information there. There is a video, in this case, a tutorial for how it works, the environment, and screenshots also. And that's the next case. It's a drone flying in the city. To show you the easiness of the sound. The user can very easily play with the speed of the drone. Yeah. And he can grasp the sound of the drone flying over, just to capture real time without any latency, this sound. It's not so easy task. It was a big task here. We make that easily tangible to anyone to try that. And then we have also the circular here case where, I don't know if you can get it, we have a special sound, so we can grasp the sound depending on the side where the drone flies to. And also have some natural experience like the joystick, you can fly it as you want alone. That's my last slide. I want to thank here the great team. It's not me behind this project. There are multiple persons behind this project. We have managed great stuff in that just 15 months. And I also want to thank also my colleagues from the digital industry software for the key insights from the customers and the continuous feedback along this process. So thank you very much for your attention. And I will be gladly answer your questions, or we can meet later and discuss in more details if you want.
Go ahead.
Hi, fascinating talk. Sorry I missed the beginning. A question, is the simulation happening still in the SimCenter product, and you are visualizing that data in your Unity project?
Exactly. So in order to get them then more easily accessible, because you have to install the SimCenter in every PC to have them access, we have developed this application, and we extract just the visualization in Unity, which runs also multiple platforms.
So if you had, second question, if you had a number of analysis that you wanted to view through this, do you need your development team to port it over, or do you have a pipeline in place to pull in that previously created analysis? Exactly.
From the load functionalities, you can load previous cases, and also you can load, which is something new, it's not here or there, predefined views. Because you as an expert can define some views, and the other can load these specific views, and they have seen that, for example, the rotation or the legend or the different bandwidths of the legend, you can predefine as an expert, and the other can load this view in the post-processing to simplify that.
Oh, hello. You said that the platform works with Meta through the OpenXR. Does that just run on Quest, or are you building for future iterations of their hardware? Does it require like link to a desktop? Thank you.
Yeah, because we are dealing with engineers, it's very important also to have a desktop version. Not all the engineers are keen to try VR experiences. As I said, that's more for people who are ready to try more immersive and younger generation. That's why we have to continue keeping on the OpenXR so we can support multiple devices and the PC version. That's also important. It's an engineer thing.
Any other questions for Theo? Thank you so much. That was excellent.
Thank you very much.
Appreciate it.